do that.
In this chapter, we will be focusing
This is
more
motion in one
on
dimension. Means
graphs and their
you're looking at objects
explanations.
that move
Okay?
either along the y-axis or move along the x-axis. See that? That's one-dimensional motion. So you're not going to be looking at objects that move over a plane. That is two-dimensional motion, isn't that? And you're not looking at a butterfly that's flying. That is 3D motion. That is going to come in the next chapter.
Dimensional motion is kind of when you drop an object and it falls due to the gravitational force and it goes down in one straight line. So now it's moving only along the y-axis. And that's a perfect example for one-dimensional motion.
Kinematics is where you look at how an object moves, but you don't worry about what's making it move. Okay, tell me, what is making this move? Force. So in kinematics, we are not concerned about forces. We are only concerned about how the object moves. Is it moving at constant speed or is it increasing speed? That is kinematics. So kinematics is the description of motion without considering its causes. Now, last class, we got the difference between distance and displacement. Who remembers? Don't read. Who remembers? One of them is a scalar. Which one? Distance. And displacement is a vector. So if an object starts from a point and finishes at the same point, what is the displacement?
That you throw an object vertically up and it goes 3 meters up and then returns to the starting point. Now it's gone 3 meters up and it's come down 3 meters. So the total distance traveled is 6 meters. But the displacement is 0 meters. And why? Because when it goes up, you take that as +3. When it comes down, it's -3. That's because displacement is a vector. And you know that +3 combined with -3 gives you 0. So that's the difference between distance and displacement. Distance is a scalar. Displacement is a major concept is that of velocity. Velocity is displacement divided by time. So if an object travels 50 meters in 10 seconds in a straight line, then we know the displacement is 50 meters and divided by 10 seconds gives you 5 meters per second. So that's the displacement. If it returns, traveling 50 meters again in 10 seconds, now its velocity is -5 meters per second. And I hope you see the difference. Because when the direction changed, the velocity became negative because it's in the opposite direction. So that's the concept of velocity. That brings us to acceleration. Acceleration is change in velocity divided by time. So in the morning, when you start, after you start your car, you step on the gas. So the initial velocity is 0 because it was not moving. And then as you step on the gas, its velocity increases. Then let's say that the velocity goes from 0 to 10 meters per second or 30 meters per second in 10 seconds. So it goes from 0, which is the initial velocity, to 30 meters per second, which is the final velocity, and that happens in 10 seconds. In this case, the acceleration is dv by dt, which is 30 minus 0 divided by 10, 3 meters per second squared.
Now, this is a concept that is the toughest for students to understand. And I'm going to illustrate that with a challenge question is coming up soon. So this is going to be 30 meters per second squared. You know how we got that unit? Because it's meter per second divided by second. Velocity is in meter per second, and then you divide it by second, right? So that's why it's meter per second squared, which is, of course, written this way too. My next question is this object at the same point it started at? Are you imagining? I mean, an object started moving.
No.
And can it be speeding up at the same position? Can. So it's moved, right? So get me its displacement right now. How much did it move? Take a few seconds. How much did it move? You don't have to hurry. It started from here. Its initial velocity was 0. And it's speeding up. It has a constant acceleration. It's right now here. And that's when its velocity is 30 meters per second. It's taken 10 seconds to get there. Its acceleration is, man, why did I put 30? Acceleration is 3, and nobody corrected me. Huh. Okay, that tells me something. Acceleration is 3 meters per second squared, isn't it? Okay. What is its displacement?
150 meters.
I'm listening to you.
Well, for every second you move 30 meters, multiply that by.
So that's your final velocity. You start with 0. No.
Why did you say that the average is 15 meters per second?
Because you have 0 for your initial and you have 30 for your final. And since it's a constant acceleration, it doesn't mean that there's some sort of spike anywhere. And so it has to be constantly increasing. And so at your halfway point, basically, it's 15 meters per second.
Very good. How do you take the average of two numbers? Add them up, divide by 2, which you can do in this case because it has a constant acceleration. He even mentioned there's no spike, there's no speeding up or slowing down. So he's right, perfect. So 15 meters per second is the average velocity. Did everybody get that? 0 plus 30 divided by 2 is 15. Once you take the average, you can imagine that it had the average for that entire time, which is how many seconds? How many seconds did it move for? 10. So 15 multiplied by 10 gives you 150 meters. That is the first equation that you can use to do problems. So I'm saying displacement delta x is average velocity, which you found out this way, multiplied by time. Isn't that what I said just now? Yeah. So that is one equation of motion that you can always use, but when it has a constant acceleration. Any questions on that? I think I saw your hand fly up sometime back. It moves. Everybody understood that? That's one way you can find displacement. So we already have one equation. Someone like, why do you even ask me this question? I will tell you. Look at the motion of this person now. Starts from home, moves 0.5 kilometers, assume in 10 minutes, and then comes back in another 10 minutes, and then moves further away. What's happening to this? This person is crazy. Maybe exercising. Okay, 1 kilometer, another 10 minutes, moving faster now, and then doesn't even stop at home, keeps going. Now, what you do is you draw a position time graph of this motion. Go ahead. Draw a position time graph of this motion, please. All right, here is the picture. Let's study it and try to understand. This is the motion, first one, isn't it? Second one, the person is returning to the origin. See that? Returning to the origin. Third, going further away. Further away, see that? And now that's 1 kilometer away from home. And then the fourth motion, watch that. All the way, doesn't stop, goes past. So that's negative. Here you see. Easy to understand, isn't it? So a position time graph will have both positive and negative. The negative shows that the person is going past the origin in the opposite direction. Clear? Okay. If it's clear, give me the velocity of this person during this part. The velocity of the person. All right, you see a statement here. I better read it for you. Very important. The average velocity is the slope of the position time graph. What do you mean by slope? The other word for slope is Okay, because I've had this word on exams and they didn't know what it is. Gradient means slope. And slope means dy by dx. So in lower classes you would say change in y by change in x, but calculus based it's dy by dx, which is the same thing, right? Change in the y divided by change in the x. Or look at that and tell me, is the slope positive or negative? Positive, thank you. And this is of course negative, isn't it? Positive and negative. So what's the slope here in this part?
That would be 0 if you're at
No, the slope is for a line. Slope is not for a point. The slope is for a line. A straight line has the slope, same slope. So what's the slope of this line? 0.5 minus 0 divided by 10 minus 0. Anybody heard me? I'll try again. The y-coordinate here is 0.5. And the y-coordinate here is 0. That's why I said 0.5 minus 0. Isn't that the change in y? And the change in x is 10, because 10 minutes minus 0. So 0.5 by 10. Come on. 0.05, isn't it? What's the unit? 0.05 kilometers per minute. Is that a proper unit? No, but that's how it is. So let's leave it there. Are you getting it? All right, just find the slope of one more part and we'll be okay. We'll move. Find the slope of this last motion here. Go ahead. What's this? The slope of a position versus time graph at a specific time. Do you see that? Gives you what? Instantaneous velocity. So remember that. If it's at a specific time, then you're saying time tends to 0. That is instantaneous velocity. If you don't have that specific time, then it's going to be average velocity. Clear? Okay. I don't know why I drew that, or why I took that from the text. Let's see why I took that. Okay. I want you to look at this position time graph and draw the velocity time graph. Hold on. How do you get the velocity from the position time graph? The slope. Isn't it? Okay. Here is the position time graph. Look at it and draw the velocity time graph. There are how many sections? 3 sections, isn't it? So 3 lines or 3 segments. Each segment will have a slope. Find that slope. What is the slope of this part? A horizontal line has no slope. So what is the object doing at that time? Not moving, not moving. You with me? Okay. And then this part, the slope is positive, this part is negative. Can you go ahead and find it, please? I'll give you time. Let's see if you understand that. Okay, look at this. Does that make sense? That's the velocity time graph. That is the velocity time graph because you see, didn't we say that it's 1 meter per second? And then we said it's not moving, didn't we? Come on. And then after that, we said it's 0.5, didn't we? Yeah. There you go. But this kind of motion, you can never practice this in life. It's never going to happen. This is just a dream. Can somebody tell me why? An object which was moving at 1 meter per second, like suddenly went down to rest. When does that happen? I mean, if you're trying to stop your car, wouldn't it take some time for the velocity to go from something to 0? Come on. I mean, even if something crashes into whatever, wouldn't that thing move at least a little bit, like 1 millimeter? Oh. So that's a dream. That's why there are dotted lines there, you see? It's like, this is just theory for you guys to understand how to go from a position time graph to a velocity time graph. Agreed? You with me? All right, next step. Give me the slope, be careful, the slope of this part. 0. This part. 0. This part. 0. Oh, the slope of velocity time graph gives you acceleration. Write that. The slope of velocity time graph gives you acceleration. So the slope of position time graph gives you average velocity, right? And the slope of velocity time graph gives you acceleration. Was this object accelerating? Nope. Nope. Well, I have to do everything on this. If it was accelerating, can you draw the position time graph of an object that is accelerating? Come on. Let's see. Can you draw the position time graph of an object that is accelerating? Try. Position time graph. Time, position. I'm just interested in knowing how many will draw that. How many did draw? Put your hand up, just so I see it. Like 3, 4 people, okay. No? Okay, wait. If that's the case, what about what is that? Oh, wait, what is that? What's the difference between that first one and the second one? Second one is decelerating. What is deceleration? Negative acceleration. Means what? Means, watch carefully. If an object is going to the east and it's slowing down, then its acceleration is to the west. That should have made sense. Okay, hold on. If the object is going to the east and speeding up, then its acceleration is also towards the east. So if an object is slowing down, then its acceleration is opposite to the direction in which it is moving. That's what I said. All right? So what's happening to number 2? Is its slope increasing or decreasing? This one. Is the slope increasing or decreasing? Decreasing. Remember, horizontal is like no slope? Yeah. So you should be able to make out that. Okay? Can you give me a practical example of when you would get a graph like this? Real life example of an object that would slow down like that? Any? Stopping a car? Could be.
Rolling down a carpet.
Rolling down a carpet?
Rolling along.
Rolling along a carpet. Okay, I thought rolling down. But have you ever thought about the raindrops? Have you ever thought about how high above it comes from? And do you know, if you use kinematic equations to calculate its final velocity, after traveling such a huge distance, the velocity would have been so big that its momentum, which is a term we're going to look at, which is the product of mass and velocity, would have been so big that it would have made a hole in your head. What am I talking about? I'm talking about a raindrop. It's falling from considerable distance up, isn't it? It would have speeded up, because you know that for any freely falling object, the acceleration is 9.8 meter per second squared. Everybody knows that? Okay, I'm pushing that in here. Any freely falling object, 9.8 meter per second squared. So it means that if I drop these two from the same height, which one will hit the ground first? Huh? Both at the same time. Because acceleration does not depend on the mass. Acceleration due to gravity is the same for all objects. I'm not talking about a feather or a piece of paper, because that will be affected by the air resistance, isn't it? I'm not talking about that. Now, going back to a raindrop, I have to finish my story. If there was no air resistance, when we all walk out in the rain, we would have been carrying steel umbrellas. Steel! But because there is air resistance, you know what happens? As the raindrop falls, at first it accelerates, and then the acceleration decreases. After a certain point, it has a constant velocity. That is called the terminal velocity. Just like you've heard of terminal sickness, terminal illness means person is going away. So terminal velocity means the velocity all the way to the end. So, in one of the labs, when I ask you to draw the graph for an object falling from a big distance, your graph should look exactly like 2. That's my story. Because isn't it having a constant velocity? Because you see that? It's okay, that's what I'm talking about. All right. Take a look at those graphs. All these are taken from your OpenStax free textbook, remember. That's a position time graph. That's a velocity time graph. And that's a speed time graph. Speed is the absolute value of velocity, isn't it? Speed is just the magnitude. You see the difference. Yeah. Okay. What's the slope at this point?
0.
Because it's horizontal there, isn't it?
Yeah.
That's why you have the corresponding point here. Remember, the slope of position time gives you velocity. And the slope is 0. Are you with me?
Yeah.
The slope is 0. And this part, the slope is positive all the way till here. That's why you have positive till here. See that? And then this part, the slope is, oh no, from here, the slope is negative. That's why the slope is negative. Okay, good. What's the difference between these two? The simple difference is that velocity is a vector, so it has both positive and negative, but speed is a scalar, so there's no negative. Look at that. Are you getting it?
Yeah.
So there's no negative side. Instead, it's just continuing to go. This is very important for you because I'm going to give you this first challenge question right now. Ready? So you have this graph. You have the acceleration time graph. And it's been moving for 7 seconds, as you can see, right? This is the question, and don't jump to the answers. At what time does the object have maximum velocity? Take your time. At what time? Don't shout it, write it on a piece of paper. At what time is the velocity maximum? If you can get this, I will be sure that you got the idea of acceleration. What time is the velocity maximum? Don't shout it. Please give everybody a chance. I forgot to record this, so I just have to say that at this point, it's accelerating faster and faster. It gets to a maximum acceleration here. It's still speeding up, so the velocity is maximum at 4 seconds.
So here is a challenge question. It's a 100-meter race, and a person completes the race in 11 seconds. So you know how it is in a race, they start from rest. And so this person accelerates at a constant rate for the first 2 seconds and completes the race in 11 seconds. Find the maximum velocity that the person achieved. Again, so it's a 100-meter race. The person starts from rest, of course, and accelerates for the first 2 seconds and thereafter maintains that velocity. He completes the race in 11 seconds. Find the maximum velocity achieved.
So, let me stop you and give you a clue. Would you like that? Or somebody wants to do it without a clue? Okay. Let me give you a clue. Let's say that an object is moving at 5 meters per second. 5 meters per second for 10 seconds. What's the displacement? Say it, 50 meters. Because displacement is just velocity multiplied by time, isn't it? So 5 meters per second multiplied by 10 seconds gives you 50 meters. Easy. All right, so if you draw a velocity time graph of that object, wouldn't it look something like this?
Yeah.
Why? It's 5 meters per second for 10 seconds. 10 seconds, 5 meters per second. What is the area of that graph? 50 meters. You draw the velocity time graph of the object. That's why I was giving you a clue. And First 2 seconds he was accelerating and then maintained the velocity. So that's the 2-second mark. That's 11 seconds, isn't it? And you're asked to find the maximum velocity. Maximum velocity. And then I did tell you that if you find the area, you will get the total displacement, didn't I?
Yeah.
And what's the total displacement? 100 meters. So you find the area of that triangle, add it with the area of the rectangle, that should be equal to 100. How do you find the area of a triangle? 1/2 times base. How much is the base? 2, isn't it 2? Times the height, which we do not know, plus, how do you find the area of a rectangle? Base times height, and the base is 9, isn't it? 9 seconds. Times the height is that, which should total 100. And so 10, because you have 9 there and you have 1 there, so 10. V max is 100, so his maximum velocity was 10 meters per second.